Yes, good day, class. Thank you very much. We are meeting once again to continue with our revision in grade 10 geography. We are doing physical geography, geomorphology. Just keep on connecting and following Metric Hub. I thank you very much for your the comments, the liking and sharing of the channel. Let's grow it. Let's become a big community. We said that we develop future leaders through one click. You never repeat. You never fail. We make the journey very short. So geomorphology, we are looking at formation of landforms that are resultant landforms from volcanoes. So as you can see here, we are going to be looking at stratovolcano or composite volcanoes. What type of landforms are formed there? How do we tell that the volcano is active? Their characteristics. We also look. We are saying their characteristics. We are also going to talk about the features that are found in there, the molten material at C and D, and also the economic advantages and disadvantages of volcanoes. Volcanoes as they take place, there are also economic advantages and disadvantages that would arise there. So without wasting any time, we want to go straight into the content of today's subject so that we can be able to relate and answer the questions very well. Continental drift is going to be discussed again. So here now, I'm saying we are going also to look at the structure, the internal structure of the Earth. So what you need to know is that the structure of the Earth is just some quite interesting concept, which I guess that you should be able to understand very well and be able to relate. So as we can see, what we are looking at here now is that we have got our structure of the Earth, which is actually made of the inner core, the outer core, and then the mantle, which we are saying that these are the three layers. So when you look at it, actually we can say that it is actually Earth is made up of four main concentric layers that you should look at. So now what I'm saying is we have got the inner core. This is the inner core. We have got the outer core. We have the mantle. Also, that can also be found there. So now these layers are cyclic, or they are cycle in shape. So now what you need to understand is that we have got these layers, as to say the inner core, which we are saying is the liquid outer core, also the mantle, which is also made up of viscous molten rock, and the solid crust. So the inner core is actually dense. It's a dense ball of iron and nickel. The inner core. The inner core is made up of what? Of iron and nickel. The inner core is made up of iron and nickel. Is made up of iron and nickel, the inner core. So now we need to know the key characteristics of the Earth. So the inner core is made up of iron and nickel, and then what we need to understand again is that the outer core is actually a flowing liquid metal that generates the outer core the Earth's magnetic field. The outer core generates the outer core. It actually generates the Earth's magnetic field. The magnetic field of the Earth is generated in the outer core. And then what we need to understand again is that we have to understand again that the mantle is the thinnest layer of hot viscous rock that moves in convection currents. The mantle, it moves with convection currents, which actually and the crust is the thinnest outermost solid shell where people live. People live on the crust. So on the crust, what we need to understand again is that when we look on the crust of the Earth, we should understand that we have got the lithosphere, which is actually formed of the crust in the uppermost solid mantle. So what we need to know is that the uppermost layer, which is the lithosphere, we have the lithosphere, which again I'm saying it is made up of what? Of the crust. It is the crust and also the uppermost mantle, crust plus uppermost mantle. We are saying that that is where people live. So in that respect, we want to work straight to the question that we are given there. Anyway, there are some characteristics again which are just of interest, which you need to understand as students that the outer core is basically liquid and it is made of molten iron and nickel, and then the liquid of this we are saying the flow of this liquid metal generate the magnetic field like I just mentioned now, and therefore again the mantle is hot viscous mixture of molten rock which is partially melted and composed of silicate rocks rich in iron, oxygen, silicon, magnesium, and also aluminium. So it has got a variety of composition, the mantle, which again is the thinnest layer of the earth and is and its materials they move in slow convection currents. The mantle has got material that moves in slow convection currents, which is also synonymous to the boiling of water in the pot. And then lastly, the outer, which we call the crust, which is the outer layer, it is actually the thinnest outermost layer and is broken into tectonic plates that move due to convection in the mantle crust, in the mantle region or zone. So now we have said that. So now we have got questions here, which you just need to match the descriptions or characteristics to what? To the different layers as we have identified them there. So the layer that is made of iron and nickel, we say that it is layer C, which is made up of iron and nickel. It is made up of iron and nickel. We say that it is what? It is layer C, which it is what? The outer core. The outer core is made up of iron and nickel. The outer core is made up of iron and nickel, which is letter C, which is letter C. According to our diagram, letter C identifies the iron and nickel that is forming. We're saying that the what? It is the outer core. The outer core is the one that forms what? That is made of iron and nickel. And the asthenosphere forms part of this layer. The asthenosphere, as we can see, the asthenosphere is actually forming part of the mantle. It forms part of the mantle, which is layer B. The asthenosphere forms part. We have got the asthenosphere. Asthenosphere is found in the towards the crust. Asthenosphere is basically found close to the what? Close to the crust, which is found also in layer what? In layer B. We are saying it is found in the layer B, which we are saying it's found in the mantle. Layer B, and then in this layer, the convection current creates the earth magnetic field. We also say that is the outer what? Is the outer core, which we said it's layer C. Layer C is the outer core, which is also causing which is generating the Earth's magnetic field. And then this is the outer layer of the internal structure of the Earth. The outer layer of the external structure of the Earth is actually found on what? On layer A. A, as you can see, A is forming the outer layer, as we can see there. A forms the outer layer of the Earth, which we are saying A forms the outer layer of the what? Of the internal structure of the Earth, and then this layer consists of iron and magnesium. I'm sure that from my description, I also explained to you that we have got various minerals that are found in the what? Which are found in layer B, which I was saying that we have got a variety of minerals that are there, besides the issue of iron and magnesium, we also have silicon, we also have aluminium there. So certain times you might find out that they tell you of iron, they can also talk about aluminium is also found in that layer. We can also maybe possibly find them talking or asking you that besides iron and magnesium and aluminium, we also have oxygen that is also found there. And the silicon is also, we are saying iron, we also have silicon that is found in layer B, which is given as to say that layer B, it is what it is giving us. Layer B gives, layer B is responsible for, uh, layer B is giving us iron and magnesium. Layer B has got iron and magnesium. We are saying layer B has got iron plus magnesium plus aluminium plus silicon plus oxygen. And then we have got the layer is molten, is in a molten stage, but to have to move like liquid, which is also layer C. We are saying it is too heavy. It is made of it is actually molten, but too heavy to move like liquid. We're saying that it is layer C again. Layer C, it is too heavy. Uh, the layer C, it is too heavy, and then layer C is too heavy, and then cannot move. We are saying layer C is actually too heavy, and then what happens is that it is the one that is too heavy, and it is in a molten stage, and this layer forms this layer has got Sima forms part of the rocks that form in there. So we have got this found on the outer layer, or we found them on layer A, which is the outermost layer of the earth. The outermost layer of the earth is found in A. A is giving us where we have got the lithosphere. In that lithosphere, we have got we have to agree that we would have also Sima, and what we are saying, the outermost layer of the inner earth, outermost layer of inner earth. That is it. So we are saying that's how it is. So you need to take note of questions that comes where you are asked the structure of the earth. So we need to be quite ready and be relevant when this question comes. You need to be able to understand it and be able to explain it as it is, the way we have discussed and explained right now. So we also have rock types that I want you to take note of. We have got basically four major rock types that we have, which we say that is igneous rocks. We have got sedimentary rocks. We have got also metamorphic rocks. All the types of rocks, or each type of rock, is formed under specific conditions that determines its characteristic. So the characteristics are given in question here. What you need to know is that you need to match the characteristic to the type of rock that is given. So now, is a source of crude oil and coal. We understand that oil is also found in sediment or in sedimentary regions. We have got sedimentary rocks where we are saying that crude oil is found mostly in sedimentary rocks. So it is question 2.1. 2.2.1 is sedimentary rocks, and then rocks that are formed under very high temperatures and severe pressure. Severe pressure and temperature, extreme temperatures, results in the formation of metamorphic rocks. Metamorphic rocks are formed under such conditions, and then materials deposited in horizontal layers. I've been just trying to illustrate here. Uh, this is just a typical representation of the profiles that we can have. We can say profile 1, profile 2, profile 3, And then we have got the last one, profile 4. So these profiles are appearing in layers according to the layering, according to the deposition that is taking place. So now what you need to understand is that this is found in sedimentary. We found that common, we are saying that characteristic, it manifests itself in sedimentary rocks, as you can see, question 2.2.3. And 2.2.4, granite domes develop from these rocks. I'm sure that we have heard of resultant landforms that are formed, resultant landforms from mechanical or physical weathering, which are forming granite domes formed because of exfoliation and so forth. So now it is igneous rocks that results in such types of rocks. It is igneous rocks. And then fossils can be found in these rocks. It is also fossils are found formed under this pressure, under these deoxygenated conditions because of the layering of sediments there, which is also in what? In sedimentary rocks. And then 2.6 forms from molten material. Molten materials results in the formation of igneous rocks as well. Results in formation of igneous rocks. And then 2.2.7, um, these rocks are used for ornamental purposes like statues. When we want to decorate, when we want to do beautification, we use metamorphic rocks. Metamorphic rocks are used for such purposes. And then 2.2.8 forms the basaltic layer on the top of Drakensberg Mountain. Drakensberg Mountains are formed from also igneous rocks, which we found there, which are forming the basalt layers or basalt rocks that are formed in there. So that is one thing that I want you to take note of. We have got a diagram that is illustrating the theory of continental drift here. I'm sure you have heard this theory of continental drift, that continents were once one, the continents that we have and we know them today, they were once one super thing, which was called the Pangaea, which was just one mass of Earth before the drifting took place. So now I want us to look at these questions that are following there. We have got the continents before drifting, and also we have after, or we are saying the present as of, this is of now. We have got the before and after. So this is before continental drift, and also as after continental drift. As you can see, we now have Pacific Ocean waters that are dividing these continents. Atlantic Ocean, we have got the Indian Ocean, we have got all these, the Southern Ocean and Antarctica regions that are also formed here. The Eurasia, Africa, all these other continents that we have them now, we are saying they were once one mass of Earth, as you can see on the photograph that says before. So, define the concept continental drift. It's actually a scientific theory that identifies and explain how continents moved or drifted to different positions on the Earth's surface. The continental drift theory explains how the Earth moved or how continents moved. So the movement of the Earth resulted in the formation of the continents as we know them of now. So as you can see, I'm saying we have got these various continents that we can identify and explain of now to say that these are our various what you call we have got various continents that are existing now. So as you can see, we are saying the continental drift, it's a theory, it's a scientific theory that explains and identifies how continents moved or drifted apart from each other to different positions on the Earth's surface as we know them of now. So the next question is saying, name two continents that formed the Gondwanaland. Gondwanaland, it was formed of it was formed of South America and also Africa. We also have Antarctic and Laurasia. As you can see, the continent that formed Gondwanaland, it was South America It was formed by South America, it was formed by Africa, it was formed by Antarctica, and also Laurasia, as you can see. So these continents are the ones that drifted, that formed this Gondwanaland that we are talking about. It was formed out of all these four continents that we have here. And then what is the main reason for the drifting of continents? Continents actually drifted due to rotation of the Earth on its fixed position. We say that the Earth's fixed position, the rotation of the Earth on its axis, it's actually caused the drifting of the continents. And then explain what happens at divergent plate boundaries. When we talk about diverging plate class, when we are talking about plates diverge, we are meaning to say that they move apart. They move apart. There is separation. There is separation. As you can see, I'm saying we have got A here, we have got B there. So each is moving. This is moving in this direction, and the other one is moving also in the other direction. So we have got a gap that is going to be formed in between, which we are saying that plates have drifted. So moving in opposite direction of plates is what we call divergence. So what happens is that we have got formation of new oceanic crust. New oceanic crust forms there. We have got an ocean that forms as the plate moves apart because there is a gap, there is an extensive gorge that forms there, which we say that it results in formation of oceanic crust. And then we have got also what you call the two tectonic plates move away from each other. Obviously, when we talk about divergence, it means two plates are moving away from each other. That is one thing that I want you to understand when we look at also at plate, when we look at plate tectonics. So now, the next question is saying, give evidence that suggests South America and Africa were previously connected. In order for us to explain that Africa and South America were previously connected, what evidence do we have that can explain that? What evidence can explain that South America and Africa were once connected? They were once supercontinents. So we need to understand geological similarities. For example, similarities of fossils. Fossils that are found in both Africa and America are similar. So they identify that these fossils were formed under similar conditions, meaning to say that they look alike. We also have rock formation that matches up across the coastline of Africa and also America. We have got rock formation, rocks that are formed, matches up the coastline, the rocks that are formed, rock formation that are formed there, the matches that are across the coastline of Africa and also South America. And then we have also identical deposits in Africa and America, which are also deposits that we found there. That explains that to say that these continents were once together, were once one thing. And then we have got the next question, which is saying, how does the theory of continental drift differ from the theory of plate tectonics? Continental, give the difference between continental drift and plate tectonics. So plate tectonics and continental drift. Plate tectonics identifies that Earth surface is broken numbers of shifting plates. There are numbers of shifting plates that are formed on plate tectonics. When we talk about plate tectonics, it actually identifies the Earth's surface being broken into numbers of shifting plates that are formed, that are moving, that is plate tectonics. And then continental drift points out that the world was once a supercontinent. World was one, and then the continents drifted, moved apart, and they moved in masses. So therefore, it resulted in the continent that we know of now, which we were just explaining above there, that what continents are formed from the different places that we are looking at. And then we have got an extract of earthquake that is given here, which is extract number 1 and extract 2. So in this case, we need to understand that what is going on here is that we need to understand certain things, specific concepts here that in diagram 1, we have got in a single day on earthquake, on Earth, thousands of earthquakes may occur, but it is the earthquake that actually causes people to die. An earthquake is considered to be big if it has a magnitude of 7.0 or greater on a richer scale. So these can cause major damage. Earthquakes can cause major damage. They can cause major damage and loss of lives. On average, worldwide, about 18 earthquakes per year qualifies to be big. On average, 18 earthquakes can be classified as big. So now, what is happening is we have got extract 2, wobbles may precede some great earthquakes. New research shows that in the month before the strongest earthquake in the country's recorded history, a 2011 earthquake with a magnitude on the Richter scale that killed more than 15,500 people. The landmass of Japan shifted from east to west to east again. Those movements that researchers call wobble may have potential to alert seismologists to a greater risk of future larger subduction earthquake. So these destructive events occur where one of the Earth's tectonic slides under another one. This under thrusting gems up or binds the earth until the gem is finally torn or broken and an earthquake results because of these movements, frequent or continuous movement that we are talking about. So the instrument that is used to measure magnitude of an earthquake, we are saying that it is a Richter scale. A Richter scale is used to measure the earthquake, the magnitude on the Richter scale as it is found in the essay here. It is given that the Richter scale is used to record the extent of an earthquake. And then the next question is saying, explain why thousands of earthquakes may occur in a single day. The thousands of earthquakes that occur in a single day because the divergence and convergence of plate boundaries are daily. The movement of plates, movement apart and movement of plates results in the at plate boundaries is causing earthquakes to occur, is causing earthquakes to take place. And then tectonic plates are moving continuously. Continuous movement. Tectonic plates are moving daily, or we can say continuously, which is another reason which is causing that. Differentiate between the epicenter and the focus of an earthquake. I have already made some points here and notes when I was preparing now that an epicenter is the area directly. The epicenter is the area directly above the floor, above the focus of the Earth's surface. It is above the focus of the Earth's surface, where we are saying it's a position where the earthquake is the west. The earthquake is west at the epicenter. It is the west at the epicenter. So now, focus is an area under the surface where the earthquake originates. The earthquake originates from the focus. So it's an area under the Earth's surface where earthquake originated from. Where earthquake originated from, we call that the focus. Yeah. So why is the earthquake in Japan considered to be a big earthquake? It is because in our complex or in our essay, in our reference that we are given here, it is said that an earthquake or earthquake that or earthquakes that are, we are saying all of them with a magnitude of more than 7.0 of more than 7.0 on the Richter scale are big. When earthquake is considered to be saying it's got a magnitude of 7.0, therefore on the Richter scale it is considered to be what? It is considered to be big. And then what is a WAPO according to the researchers here? Our researchers has already showed us that is the movement of tectonics. WAPO is the movement of tectonics, tectonic plates from east to west and to east again. So it actually shows a continuous movement of what? Of tectonic plates. It's a WAPO. That's what we call a WAPO. And then up. What happens at a subduction zone? At a subduction zone, what happens at a subduction zone? Subduction zone, it is where plates, tectonic plates slide under each other. At subduction zone, plates at subduction zone class. There's one point that I just want to enlighten here. At subduction zone, the plates, they slide, plates, tectonic plates slide under each other. Plates slide under each other at the subduction zone. Plates slide under each other at the subduction zone. That is one thing that we need to understand. Plates slide under one another. I'm sure that if you can refer again from our comprehension, it is given that subduction zone we are saying they've got greater risk at future because plates we have got plates destructive events occur where one plate eight tectonic plates slide under each other, under one another is the subduction zone. This is what is happening at the subduction zone there. And then according to the extract, explain how an earthquake develops. According to the to the extract, explain how an earthquake develops. So we are saying that the interesting gem, the anti-thrusting gems are where one earthquake plate tectonic slide on each other. This unthrusting jams up or binds the earth until the gem is finally torn and broken and an earthquake results. So our answer is coming from the point which we are given here that there is unthrusting gems up and binds, which also until the gem finally turns and then broken up and then the earthquake results. So in this case, what we need to understand is that when we talk about the development of an earthquake, it is actually under thrusting gems up or binds the earth. We have got under thrusting gems up or binds the earth. It jams off or binds the earth, and the gem actually broken, the gem actually torn, resulting where the gem it will finally turn away. It turns, resulting in an earthquake. Resulting in an earthquake results from the under thrusting gems up or binds the earth where the gem will finally turn, resulting in an earthquake. then we call that earthquake happening. So we have got the last condition here, which we're saying the stratovolcano or the comsite volcano. We are given the stratovolcano or comsite volcano here, which is given and shown on the diagram here. So now the question is saying, why this volcano be regarded as what? Why is the volcano being regarded as active? For us to say that the volcano is active, what is the reason? Which can cause a volcano to be active? It is because we have got uh, action, active, meaning to say that something is still happening. It is too destructive. Something is still happening. So what happens is that we have got eruptions that are evidently taking place. Eruptions are evidently still taking place. Eruptions are actively they are actively taking place. Therefore, we can say that the volcano is active, which is shown by all these various uh, what you call layers of layers that are accumulating here. We have got layers of hardened rock and ash that we are seeing here. We still have volcanic bombs that are coming out. We have got also the steam that we can see through these the main vents and all those things that are shown on the diagram. And then give two characteristics of stratovolcanoes. Uh, they are very, what are the stratovolcano characteristics? As you can see them here, we are seeing that the stratovolcanoes, they have got alternative layers of lava, and each side they've got layers that are seen there. Layers are accumulating. You have got layers that are the layers of lava flow. Layers of lava flow, we have them. Layers of lava flow, we see them there. So therefore, what we are saying is that characteristics of stratovolcanoes is that they have got alternative layers of lava flow. One is alternative or layered. They have got alternative layers of lava. We have got alternative layers of lava flow, which is also shown as we can see the ash, and we also have the ciders that are the characteristics. As you can see, we have got the ashes that are being shown here. We have got also the ashy cloud that are shown there. We said the hardened layers that are accumulating there. And then at the same time, we also have that they have got a symmetrical shape. They've got, they have a symmetrical shaping. And then we can also say that they also have very steep sides. Comsite volcanoes also have very steep, they have very steep sides also, which you can see here. The sides are very steep. These are steep sides that we are talking about. Steep sides. We have got steep sides that are formed there. They have got very steep sides that we can see. And then identify features A and B of the stratovolcano. What is features A and B? A, we can see that A, it's a side vent. This is a side. This is a side vent. And then obviously B is the crater. B, we have got the crater that is forming there. B is the crater. So A is the side vent. And then B is the crater. that you can see there. Name the molten material at C and D. The molten material at C and D. At C, where is C? C when it is actually on the Earth's surface. When it erupts, it is called what? It is called lava. And then when it is inside when it's within the Earth, it's called magma. So we are saying this is uh, this is magma because it is still under the earth. It is within the earth's crust, and then when it erupts there, it is called what? It is called the lava there. It is called the lava. When it is out there, it's called the lava. So we are saying D is called magma, which is we are saying underground. When it is underground, it is called magma, and then C, it is called lava. After erupting on the Earth's surface. On Earth's surface, we call that what? We call it lava. And then we want to see and identify the economic advantages and disadvantages of what? Of volcanoes. What are the economic advantages and disadvantages of volcanoes? So volcanoes, as they appear, let's start with the advantages. The advantages, we say the benefit. One, we are saying the result in mineral deposits, minerals from down underground. It results in mineral. It results in mineral deposits that are taken from deep underground. They are exposed to the earth as the volcanoes erupting from deep down, from the lower levels of the earth's surface. We also talk about it also promotes generation of geothermal energy. Promotes generation of geothermal energy. We are talking about the energy that is coming from underneath the earth. Geothermal energy is produced as a source of energy, which is mostly produced. This one, it is a source of energy mostly available in developed countries. We can talk about that in developed countries due to the equipment and technology that it requires. So it is a form of energy that comes from the ground, which is also resultant or used in terms of human sources of energy. We can talk about also it also creates beautiful landscape that promotes tourism. We are saying it promotes uh, scenic viewing, which attracts tourists. When we talk about tourists, obviously we talk about creation of employment. We have got also a source of income, which we are saying foreign currency. Foreign currency is also earned in here. We also have the country earning foreign currency in that regard as a result of tourists. People would come and see the beauty of the landscapes that are resultantly formed from this. And then it can also increase the soil fertility, aids in soil fertility, which is good for agricultural purposes, which is important for our agricultural crop farming, the fertility of the soil, especially when we have got the lava cools down and then it cools down and then it erodes some elements that can also increase in terms of soil fertility. We can also have an instance to do with the natural fertilizers that are rich in various minerals. The natural fertilizers that can also be promoted in terms of that. Let's look into disadvantages. Disadvantages, the disadvantages that we can have as a result of this, uh, the lava actually flows are destroying crops and livestock. Lava, it destroys natural ecosystems. It destroys our natural ecosystems. It destroys our natural habitats. Natural habitats are destroyed. We can also talk about this. Remember that the lava is very hot. I'm sure that we have seen where we have got volcanic eruptions, where we have got earthquakes. So what we are saying is that uh, volcanoes, the volcanoes actually destroys ecosystems because the rocks or the molten magma which erupts to the earth's surface as lava now, it is burning animals, it is burning vegetation, and then it can also it actually also produces harmful gases that can also destroy that harmful gases harmful gases are produced which can affect business, which can affect they affect people, they affect people and businesses. So human life is livelihoods are put at risk because of the toxic gases that are produced there. We can also talk about the issue of actually also the reduction in tourism also. Tourism may also be tourism is also negatively affected, is also negatively affected because of the destruction which is caused because of the volcanoes that we are talking about in this case. There is also increase in global warming which can cause droughts and floods. In this case, global warming, which is actually caused because of the heat, extensive heat, uh, extensive heat may result in global warming. Global warming, we are talking temperature increases, temperature increases, temperature increasing, which will causing drought. We can also resulting in desertification. Our ecosystems are are seriously affected, and that would cause also problems that would affect in the long run. Even infrastructural destruction, the volcanic eruptions will also destroy uh, uh, our destroy infrastructure. We can talk about the roads are destroyed because of that. There is destruction of infrastructure. That is also a serious problem that we cannot also just not which we can also not just overlook. So when you look at this, just to try to relate and identify many other climatological factors that affect agriculture, that affect economic activities, that would cause businesses to be at standstill, which can also cause losses when businesses are not operating. That alone is a disadvantage. That is also economically as we look in terms of financial returns or financial benefits that the business or the country is expecting, affecting our GDP, gross domestic product is affected because we also even have lives being lost. We have got also a continuous investment in consolidation or in terms of reclaiming land and all the problems that might have been caused because of these volcanic eruptions. So, class, thank you very much for your time and keep following and liking our channel, sharing, and also don't forget to subscribe and share to friends and families. With one click, we can develop future leaders who can be extensively excellent. Have a beautiful stay and all the best in these upcoming exams. Thank you.